All right, ladies and gentlemen, I'm sorry that I couldn't be here today, but we're still going to go over the lesson, so make sure that you turn your notes to page 10. We're going to take a look at day 3. It's just 2 pages, so let's take a look. We've got an exponential function, and these are in the form of f of x equals b to the x power. So there's a couple things that need to be true. B needs to be greater than 0, and b cannot equal 1. So why? Let's take a look. Why can't b equal 1? Well, what if we had f of x equals 1 to the x power? What's 1 raised to any power? 1 raised to the 4th power is 1, 1 raised to the 700th power is 1, 1 raised to the negative 5th power is 1. It doesn't matter. It's always going to be 1. So if it's always going to be 1, it's not going to have that exponential curve that we want. Why can't b be 0? Well, what if we take f of x and raise b to the 0 power? What's anything to the 0 power? Again, always 1. So these are why we can't do them, is because if we always have 1, we're going to have a constant function. It's going to be a line at 1, and it's not going to be an exponential function. So b equals 0. What happens if b is at negative 2? Let's take a look at that. I'm sorry, b is greater than 0. Well, what if we had f of x equals negative 2 to the x power? What's negative 2 to the first power? Negative 2 to the first power is, oops, that should be a 1, is negative 2. But what's negative 2 to the second power? Uh-oh, that's positive 4. And then negative 2 to the third power is going to be negative 8. And what's going to happen is we're going to keep bouncing back and forth from negatives to positives, and again, we won't get those nice curves that we want. So b can't be 1, b can't be 0, and b has to be greater than 0. So let's take a look at a parent function. We've got this function 2 to the x power. So you could make a table, but you could also grab your calculator and look at the table. So I'm going to grab one right now.